Welcome to Physics Can Be Fun with me, Stephen Thomas. Today we're doing an exercise on projectile motion. Now I've chosen this exercise from the latest NSC, the National Senior Certificate Physics exam. Now a word of wisdom to students and teachers. Always study the last 3 years' papers. This must be a priority. This cannot be just something you do incidentally, because the last 3 years' papers sets the tone for the exam that you're going to write at the end. It's usually the same old suspects who set the papers, and from my experience, the questions are always alike. And this is no exception. In fact, this is quite a nice, interesting gift of a question, and it's your first question in the section B. Let me explain it to you and see how easy you would find this. We have a building. Does that remind you what we've been doing? Now a ball is thrown upwards at 8 meters per second, and then it falls down, and after 4 seconds, it hits a balcony, then it bounces upwards, and after a further 6 seconds, the problem explains, it then hits the ground. You've got to calculate at what velocity it hits the balcony with. So really quite an easy problem, and then they ask you to draw a graph of the motion, the velocity of the ball in the whole 10-second period that it's in the air. So how do we work it out? Well, the first question they ask is the object's acceleration at its maximum height upwards, downwards, or zero? Now folks, they are actually trying to help you out here. They're saying choose a direction that is positive. And what is our convention? If our ball starts by going upwards, I don't even think further. I then go and write as my direction, the starting direction, upwards, positive. So I always choose the starting direction as being positive. But now we've got to bear in mind that we've got acceleration due to gravity, which is not, it's always downwards. So we must be scrupulous that this is now going to be downwards, therefore negative. Our g, or acceleration, is negative. So even while the ball's in the air, the gravity is negatively pulling it down. Even though it starts by having a positive direction, gravity is always negative. And we can work out our answer by going to one of our 4 equations of motions. Like I've said, you'll find them all on your crib sheet, otherwise known as your BFF, otherwise known as your data sheet. And there you're going to find the 4 equations of motion. And you're going to look for an equation that's got the starting velocity, the final velocity, and something else. And here is an equation of motion. Final velocity is equal to initial velocity plus a delta t. And we're trying to find the final velocity when it hits the balcony after 4 seconds. So it's a good practice. What is the time for? What is a, or g? It's a negative minus 9,8. What is v initial? Well, they tell you that it's going upwards at 8. So v initial is positive 8. And there we go. We just now plug in our values. Initial velocity is 8 plus minus 9,8 minus 9,8 times delta t, 4 seconds. And let's put that into our calculator. We've got 8 plus minus 9.8 times 4 times 4. Times 4 And that gives us an answer of minus 31,2. Minus 31,2. V final must be meters per second minus upwards positive, so that is down. And there we go. There's our answer. So after 4 seconds, the ball will be traveling at minus 31,2 meters per second. So that was calculate the velocity of the object when it strikes the balcony. And then second question, height of the balcony above the ground. So now we've got to calculate the height of the balcony above the ground. So we're going to choose a formula from our equations of motion. We go again to our equations of motion, and we're going to choose something that involves delta y. And delta y is equal to, here we can choose our formula. Let's see, space-wise, where can we do it? Here. Delta y equals V initial delta t plus a half at squared. Delta t squared. And there is our equation of motion. Let's plug in our values. V initial again was 8. Delta t was times 4 plus a half a, which is 9,8. Remember, minus 9,8. And times t squared, 4 seconds squared. And when we plug that into our equation, let's work out the height of the balcony. And don't forget, we're going to be measuring it from there to there. Again, check that you've got your directions correctly. V initial is positive and G is negative. So we have 8 times 4 plus 0.5 times minus 9.8 times 4 times 4 minus 46.4 meters. So what it's telling you is from where we started to there is downwards minus 46.4 meters. So what is the height of the building from the ground? Well, what we've got to do is we take the height of our building, which is 60. We subtract the 46.4. And the height of the building is going to be therefore 60 minus 46.4. And the height of our balcony is 13.6 above the ground. So although we've worked out how much it fell in that 4 seconds, the height of the balcony is, height of balcony is 60 minus 46.4 equals 13.6 meters from ground. .6 meters from the ground.